I'm recording the session. So switch on your camera. The position time graph. We will start with the position time graph. Who will note the attendance? Bhanvi, can you note the attendance of the students?
So I'm assigned for the attendance.
Who will note the attendance?
30 up to.
Okay, okay. Send me after the class quickly.
Okay, sir.
So we are studying position time graph. So it's a position time graph. Along the vertical axis, we have plotted position in terms of meter, the position in meter, and along the horizontal axis, time in second. Position in meter and time in second. And it's a line, sloped line, AB. And at time T1, at time T1, 1 minute. At time T1, the position of the object is x1. So point A is a point on the given graph, and the time when the object was at point A is T1, and its respective position is x1. Similarly, at point B, the time is T2, time changed from T1 to T2, an object reached from point A to point B. So at point B, time is T2 and the position is x2. So what we notice here, we are noticing here that along with the time, the position is also changing. And at the very beginning of this line, at this point, the position is plotted as x0. X0 means initial position. Initial position, as the object started to move, it reached at point A. At point A, time was T1 and the position changed from x0 to x1, x0 to x1. And as the time reached to time T2 seconds, object reached at point B, and the position changed from x1 to x2. So are you able to understand the graph? Is it clear, students? Okay. Those who are not able to understand, just raise your hand. I will explain it again. So it's a position time graph for the uniform motion. As the heading is there, the position time graph for the uniform motion. So who will tell me what is uniform motion? Uniform motion is the motion in which the object covers equal distances in equal intervals of time. That is called uniform motion. So the uniform motion of a particle or of an object is plotted on this graph. Next point. The slope of the position time graph gives us the velocity of the uniform motion. The slope of the position time graph gives us the velocity of the uniform motion. Take the screenshots. So what is the slope? Slope of line AB. Slope of line AB is the perpendicular upon base. The perpendicular upon base is called the slope. So from triangle, you are seeing that it's a right angle triangle, triangle A, B, C. Right angle triangle having three vertices, vertex A, B, and C. So BC is the height or the perpendicular, AC is the base. So slope of the graph is the ratio of height and base of the triangle. So this slope means the velocity of the uniform motion. That is BC upon AC. Or we can write in terms of velocity is change in position with respect to time. So I explain it in the class. Change in position with respect to time change in position. So final position minus initial position is the change in position. So who will tell me what is the final position in terms of the slope AB, from slope AB? What is the final position? Yes, Shubham, tell me what is the final position?
Sir, it will be B.
No, but I'm asking the position. B is the point, position is x2. Position,
Yes.
it is started from A to B. Now we are considering the motion between A to B. So x1 is the position at point A and x2 is the position at point B. And
Sir, so X2 will be the final position.
is it clear? Now who will tell me what is the final position again? Anyone? Yes, Ronak, beta, you tell me.
Sir, X2.
Yes, x2 is the final position minus what is the initial position then? Yes, Anya, China.
Or it's x1.
Yes, it is x1. So velocity is change in position. Velocity is change in position. So in place of change in position, we will write x2 minus x1 upon change in time. So what is the final time, beta? What is the final time? In this case? Yes, Ronak, what is the final time?
Sir, T2.
Yes, it is T2. So we have subtracted T2 from, we have subtracted T1 from T2. This is the change in time. So change in position upon change in time is called the velocity. So we calculated the velocity of the motion from the given graph. So it's a position time graph whose slope gives us the velocity. And the object is moving in uniform motion. Is it clear? Is it clear, students?
Yes, sir.
Okay, beta. Quickly reply. I will share the recording of the class with the respective group. So now velocity time graph. Yes, Shubham.
Sir, I wanted to say that did you receive my paper?
Sorry.
Sir, did you receive my paper? You didn't told
Shubham.
my name. Yes, sir.
1 minute.
Sir, because I've sent the screenshot also to you. Just now.
Shubham Shukla. Nahin.
No, sir, Shubham Kumar.
No, Shubham, I didn't receive.
Sir, I've sent the screenshot to you as well, just now.
All these students, share me your screenshot.
Sir, I've
Because
send
I
it to you
didn't
just
receive
now.
from the many students.
So have you
Okay.
received the
So
screenshot?
we see a screenshot of your sent answer sheet of periodic
Yes,
test
sir.
of
Excuse me,
physics.
sir.
Yes.
Sir, I just want to inform that, sir, I want to inform that my group is in my mother's school and she comes at 3:30, so I will not be able to send you after the class.
Okay, contact me after the class. Those who note or those who sent their respective answer sheet, but I didn't receive na. Call, message me on WhatsApp after the class. Okay.
So can
So
you once
velocity.
again take the names for the children whose paper you did not receive?
I'm taking the name from those who I received. Huh? Usha Goyal, Avni Goyal, Grant Malhotra, Vijay Arora, Hardik Bell, Dipanshu, Saurabh Shukla, Daniel P, Mrinal Patel, Sayam Samanta, Kunal, Gauransh Meena, Akshit Arora, Vijendra Kumar, Stuti Raj, Krishna Sharma, Sukhbir Singh, Ananya Yadav, and Avika Arora. I received the answer sheet of these students only. So it's a velocity time graph again. So see the horizontal line. It is the horizontal line. It is the horizontal line which is parallel to the time axis. And now on the vertical axis, we have plotted the velocity. If the velocity increases, suppose that at a particular instant of time, the velocity is here, the magnitude of velocity is this, and the velocity increases, this point will move in upward side. So it's a velocity v of the object which is moving with velocity v, and velocity remains the constant. So velocity is not changing. When the velocity will decrease, it will approach toward the origin O, and when it will increase, it will move away from the origin. It will move away from the origin, but time is continuously changing. So initially the time was 0, then time became t1, then time became t2. But the velocity remains the same. At point A, the velocity was v. At point B, the velocity was still v. And at time t1, the velocity was v. At time t2 was the velocity same. So it is the area under the graph AB. So area under velocity time graph gives us displacement. So the area under the velocity time graph gives us the displacement of the body in uniform motion. Before your periodic test, I also explain it on the board in your class. So I'm just revising that through the PPT. So this is the area. So area under the graph represents the displacement. So this is the displacement. The magnitude of this area represents the displacement. So you can note it down. The area under the velocity time graph gives us the displacement. So what is the displacement here? So displacement, suppose that it's the final position x2 and it is the initial position. So change in position is called a displacement. Change in position with respect to the surrounding is called displacement with the passing of time. So this x2 minus x1 means change in position is the area of ABCD. Is the area of ABCD. So ABCD, it's a rectangle which formed by this graph. So the area of this rectangle represents what? The magnitude of the displacement. The magnitude of the displacement. So have to calculate the area of a rectangle. It is length into breadth. See, if I ask you what is the length and the breadth, if I say what is side AB, so side AB or side CD, I can take one of the sides, side AB or side CD. So let's say side AB. What is the value of AB? AB is representing the time here. So it is from here to here T2 minus initial time T1. And if I say what is side AD, who will give me the length of AD? Anyone? Shubham Kumar, are you there in the class?
Yes, sir.
Yes, beta, you tell me what is the value of side AD?
So can you repeat the question?
We are calculating the area of the
Yes, sir.
graph. And so in order to calculate the area, there is a geometrical figure formed by these 2 points under the point AB. So ABCD is a rectangular. That we have to calculate the area of the rectangle. I have calculated one side AB. AB is final T minus initial T, that is T2 minus T1. Now we have to calculate side AD or BC. AD or BC.
Yes, sir.
So what should be the value of AD or BC?
So what should be the
So,
value?
so final point is A with respect to the origin. So at point A, velocity is V, and at point D, the velocity is 0. Okay,
V
so
minus
it is
0.
only V. So this side represented by the magnitude of the velocity, and this side is T2 minus T1. So we will multiply AB into AD, and then we will get this entire area under the curve AB or under the line AB, which will give us the magnitude of the displacement. So the displacement, which is denoted by S, will be AB into AD. The value of AB is T2 minus T1, and the value of AD is V. So I have already explained it here. So this gives us the magnitude of the area. V into velocity into the difference in time or change in time. Is it clear?
Yes, sir.
Okay, note it down. Students, I ask you to switch on your camera, and most of the students have not done that. Okay, take the screenshot. Take the screenshot and note it down after the class. So the main key point is that the area under the velocity time graph gives us the magnitude of the displacement. The area under the velocity time graph gives us the magnitude of the displacement of the body in uniform motion. So now in non-uniform motion, non-uniform motion, the particle is said to have non-uniform motion if it covers unequal displacements in equal intervals of time. When it covers equal displacements in equal intervals of time, then the motion is called uniform motion. When the displacements covered are unequal, then it is called non-uniform motion. So non-uniform motion is called accelerated motion. It's called accelerated motion. So when the velocity changes with respect to time, the motion is called accelerated motion. So if the velocity of a body changes either in magnitude or in terms of direction or both, then it is said to have acceleration. So velocity can change in terms of direction, in terms of magnitude, or in terms of both. Note it. Am I audible, student?
Yes, sir.
Okay, beta.
Yes.
I think you have noted it. Okay, okay. So for a freely falling body, if the velocity changes, for a freely falling body, the velocity changes in magnitude and hence it has acceleration. I showed it practically in your class. Did you remember that? With the help of a piece of chalk, na? So for a body moving round a circular path with a uniform speed, the velocity changes in direction and hence it has acceleration. So the body moving along the circular path also describes accelerated motion. So one minute. Huh? So uniform acceleration. So if equal changes of velocity take place in equal intervals of time, however small these intervals may be, then the body is said to be in uniform acceleration. or the body has uniform acceleration if its velocity changes at a uniform rate. So that's such that the velocity of an object is changing at the rate of 2 meters per second. So velocity is changing at the rate of 2 meters per second, then the motion is called uniformly accelerated motion. So suppose that the motion of a freely falling body is uniformly accelerated motion. Suppose that the body is at some height h, and a ball is kept over height h. When the ball falls from some height near the surface of Earth, so it describes the uniform motion, uniform accelerated motion. See it again. If a body drops from some height, its motion is along the straight line. It is describing the motion along the straight line. Also, it is uniformly accelerated motion. Is that clear? Is that clear, students? No.
Yes, sir.
Yes.
Okay, I'm explaining it. So if a body drops from some height, it describes the motion along the straight line. So it has rectilinear motion, and its velocity is changing. It is increasing at every point towards the Earth as it is approaching the surface of the Earth from some height. So at every point, the magnitude of velocity is changing. So because there is a change in velocity, hence the motion of the freely falling body is accelerated motion, uniformly accelerated motion. Is it clear now? But the direction is same. In this case, direction is same. The motion of a sliding block on a smooth inclined plane is uniformly accelerated. Suppose that it's a this is called inclined plane. This is called inclined plane. So you will study it in depth in 11th class when I will teach you the free body diagram. The motion of a sliding block on a smooth inclined plane is uniformly accelerated again. So when you remove the support from the block which is kept on the inclined plane, it will slide down. Is the PPT visible, students?
Yes, sir.
Okay. So suppose that this block is kept at the height or on the top of the inclined plane. It is supported by this rod. When we remove the rod, the object moves towards the bottom of the inclined plane. In this case, also the motion is uniformly accelerated. The body is said to be moving with non-uniform acceleration if its velocity increases by unequal amounts in equal intervals of time. Or we can say a body has non-uniform acceleration if its velocity changes at a non-uniform rate. Example, the motion of a car on a crowded city road. Its velocity or speed changes continuously. So let's see the next example. So there is a car on the straight road and it is moving. So what you noticed in this example, students? Again, watch it carefully. There is a car which is moving along the road, straight road. Come on, Akshit, can you tell me what you noticed in the motion of the car?
So that speed is not constant.
Yes, speed was not constant. Initially, it started. Initially, it started. 1 minute. It started from rest and then applied the brake, then again started. So there was variable velocity. there was a change in velocity, and therefore the motion is called non-uniform or non-uniform accelerated motion. So this is called retardation or deceleration or negative acceleration. This also I explained you in the class. The negative acceleration is here. When you apply the brake, it causes retardation. Means the acceleration is against the motion or in the opposite direction of the motion. So a body is said to be retarded if its velocity decreases with respect to time. Again, see the next example. So it was moving uniformly, but the brake was applied. So car was in motion. It was a high-speed car. Then the driver applied the brake and it stopped at the end of this road. So this is called retardation, because when we applied the brake, this also causes acceleration, but acceleration is negative with respect to the motion. So it kills the motion and brings the body at the rest. So this is called retardation or the negative acceleration or deceleration. Is it clear? Students, is it clear?
Yes.
Okay, take the screenshot. Take the screenshot of the PPT. Position time graph again. Uniformly accelerated or the positive acceleration. So we have taken two axes. One is vertical, the another is horizontal axis. Along the horizontal axis, the time has been plotted. Along the vertical axis, we have position, the object. Now the graph, which is not a straight line. It is not a straight line, it's a curve. This represents uniformly deceleration. Uniform deceleration. So this side, uniform acceleration. This left hand side, this graph is positive acceleration. On the left hand side, it is deceleration. Uniform motion, zero acceleration. Uniform motion, zero acceleration is the straight line. When the curve is downward with respect to the time axis, so or toward the time axis, so this is called positive acceleration. When the curve is away from the time axis, that is called negative acceleration. When the line is straight between the position and the time axis, the motion is uniform motion, means acceleration is zero. So it also I explained it in the class. I think you remember that. In that case, the acceleration is increasing, where